The second type of application we're going to look at are uniform motion applications. These deal when we're traveling. So we want to think about what is the rate or speed at which we travel and how long have we traveled. You may know this as the distance formula, right? Distance equals rate times time. For instance, if I drive a car at 60 miles per hour for 2 hours, I have gone a total of 120 miles. And so we're going to apply this whenever we have two unknowns. Those two unknowns might be the speed of a plane, the speed of a wind, and we're going to see how we can think about how the wind affects the speed of the plane. So I have a chart with the speed of the plane in still air, then the speed of the wind. Then we want to think about what is the speed of the plane with the wind. So that is, if it is directly behind the plane, how does it affect the speed? And then the speed of the plane against the wind. That is, if the plane is driving straight into the wind, how does it affect the speed of the plane? Well, let's suppose our speed of the plane is 500 miles per hour and the speed of the wind is 20 miles per hour. If the wind is at its back, so this plane is traveling with the wind, then it will actually increase the speed of the plane by the wind speed. So that is, the speed of the plane with the wind would be 500 miles per hour plus the wind speed, 20 miles per hour, for 520 miles per hour. But if we are flying directly into the wind, the plane speed is slowed down by the wind speed. That is, the speed of the plane against the wind is 500 minus 20, or 480 miles per hour. So now what if we have the speed of the plane is 600 miles per hour? We don't know the speed of the wind, so we'll call it x. Then the speed of the plane with the wind, whatever it is, it just adds to the plane speed to be 600 plus x. The speed of the plane against the wind would be 600 minus x. Now, if the wind is blowing in at an angle, then you actually have to use some trig to figure out how the plane speed is impacted. So we're only going to do either directly head on or directly behind. So here's an example. The distance from Chicago to Atlanta is about 590 miles. While traveling with the wind, the flight took 1.7 hours. While traveling against the wind, the flight was 2 hours. Find the wind speed y and the speed of the plane in still air. So we know some information, and we're going to organize it in a chart. We have rate times time equals distance. And then we also have down in our rows with the wind and against the wind. So with the wind, we know that the flight took 1.7 hours. So I'm going to put that in the time column. Against the wind, the time was 2 hours. We also know the distance to and from is 590 miles. So we'll put 590. But in this case, we don't know the speed of the plane. It is x. And we don't know the wind speed, which is y. But we do know how with the wind and against the wind impact it, right? So to go with the wind, that is going to add to the plane speed. So that would be x plus y for the total speed. And then the plane against the wind gets slowed down by the wind speed. So it would be x minus y. So we have these two rows, and we know the relationship rate times time equals distance. So we can multiply across to get our two equations in the system. And they will be 1.7 times x plus y equals 590, and 2 times x minus y equals 590. The first thing we need to do to solve the system is simplify each equation by applying the distributive property. So we get 1.7x plus 1.7y equals 590. And then 2x minus 2y equals 590. Now we don't like decimals in our equations, and so we can multiply each side of the first equation by 10 to clear out those decimals. And the other thing you might notice is that in the second equation, there's a common factor of 2. So if you wanted to, you could divide the second equation by 2 just to make the coefficient 1 on one of those variables. So those two actions would give us this new system that is equivalent, but it would be 17x plus 17y. And then 10 times 590 is 5,900. And when we divide by 2 on the second equation, we get x minus y is equal to 295. We can use addition to solve this system. If we try to eliminate the x variables, notice that the common factor between 17 and 1 would be, or not common factor, common multiple would be 17. We already have the positive 17x, so we need a negative 17x on the second equation, which we can achieve by multiplying by negative 17. So our new system would become 17x plus 17y equals 5,900. And then distributing by negative 17, we get negative 17x plus 17y is equal to a negative 5,015. So we can add the equations together to get 34y, and 5,900 minus 5,015 is 885. So if we divide each side by 34, we get 26.03 if we round to the hundredths place. So this would tell us the wind speed is about 26 miles per hour. Now, how do I find the plane speed? Well, I can plug into one of those equations. We know that x minus y equals 295. We can replace y with 26.03. And then add that to each side to get x is 295 plus 26.03. And that is 321.03. So the plane speed would be 321.03 miles per hour, and the wind speed would be 26.03 miles per hour. Now, one last example is not really relating to uniform motion or mixture. It is just kind of a random relationship between two quantities. So this one is the top 2 most profitable Fortune 500 companies in 2016 were Apple and JP Morgan Chase & Company. JP Morgan Chase & Company's revenue was $29 billion less than Apple's revenue. The total revenue for both companies was $77.8 billion. What was the revenue for each company? And so here we don't know the revenue for either company. So we don't know A, which is Apple's revenue. And we don't know J, which is JP Morgan and Chase revenue. But some things that we know, it says that JP Morgan Chase & Company's revenue was $29 billion less than Apple's. So J is 29 billion less than Apple. So we would have A minus 29. And then we know that the total revenue for both companies was $77.8 billion. So we know that if we add A plus J, we will get 77.8. So that is our system that relates the two unknowns. Now we can solve this by substitution because we already have J solved in terms of A. So if we let J be A minus 29 in the second equation, we would get A plus A minus 29 is equal to 77.8. So simplifying, we get 2A minus 29 equals 77.8. And then we can add 29 to each side to get 106.8. And then divide by 2 to get 53.4. So Apple's revenue in 2016 was $53.4 billion. Now JP Morgan and Chase, to solve for J, we know that J is A minus 29, so 53.4 minus 29, which is 24.4. So we would need to kind of simplify or write this out to say that JP Morgan and Chase revenue was $24.4 billion. Apple's revenue was $53.4 billion.